The ability to evaluate a wide variety of different types of limits is one of the skills that are necessary to apply the techniques of calculus successfully. Limits play a fundamental role in the development of the derivative, and limits are an important graphic tool. In order to deal with graphs effectively, we need to develop some more method for evaluating limits. In this section, we discuss a powerful techniques for evaluating limits of quotient, which is called L'Hopital rule. To use L'Hopital rule, it is necessary to be familiar with the limit properties of some basic functions. L'Hopital rule can apply the quotient limit when 0 over 0 or infinity over infinity indeterminate form occurs. So, recall that limit when x approaches c, f of x over g of x is a infinity over infinity, okay, indeterminate form. When this occurs, if limit of f of x equals 0 when x goes c, and limit of g of x equals 0 as x approaches c. So the quotient properties of limit, which is given in chapter 2, does not apply since limit of g of x equals 0. In this way, generally we find the common factors, and by cancelling common factor, we can solve the limit. For example, x squared minus 4 over x minus 2. When x goes to, we have a 0 over 0 indeterminate form. So we know x minus 2 is the common factor here. So by cancelling the x minus 2 terms, factors, because x is different than 2, we say this limit equals limit of x plus 2 when x goes to, so which is 4. But if both quotient in the quotient numerator and denominator are the polynomial, you can use this idea. For example, if when x goes to 1, e to power x minus e over x minus 1, if we have this limit, we cannot use the that strategy, but we cannot cancel the common factor. We cannot make some simplification. So we turn to the powerful L'Hopital rule, which we state without proof in the discourse. Okay. This rule can be used whenever a limit is a 0 over 0 indeterminate form. So it can be used to evaluate both of the limit in the this both of the limits. Okay. So what the L'Hopital rule, what the L'Hopital rule theorem says? L'Hopital rule for the actually here this is for 0 over 0 indeterminate form. In the future, we will generalize for the infinity over infinity indeterminate form. Okay. For C, a real number, if limit f of x equals 0 when x goes c, and limit g of x equals 0 when x goes c, then the theorem says limit of f of x over g of x when x goes c equals limit of derivative of the f of x over derivative of the g of x when x goes c. Okay, of course, provided that the second limit, right hand side limit, second limit exists, the meaning of existence is a real number, or the limit is infinity or minus infinity. Okay, so the theorem remains valid if the symbol x goes to c is replaced everywhere it occurs with one of the following one: x goes c from left side, x goes c from right side. This is also valid for this case. X goes to plus or minus infinity, okay, or minus infinity. It is valid for these cases. As the application, let's show that quickly. For this limit, when x goes to x squared minus 4 over x minus 2, there is a 0 over 0 indeterminate form. So by applying L'Hopital rule, when x goes to derivative of x squared minus 4 is 2x, derivative of x minus 1 is 1. So this limit is 4, okay, by L'Hopital rule. For the second one, limit x goes 1, e to power x minus e over x minus 1. Here we have a 0 over 0 indeterminate form. So by using L'Hopital rule, separately we calculate derivative of numerator and denominator. Derivative of numerator is e to power x, derivative is e to power x minus derivative of e is 0 over derivative of x minus 1 is 1. So we have e to power x. So when x goes to 1, this limit is e. At test steps, I would like to make some remark. Some limits does not involve the quotients, which has 0 over 0 indeterminate form. Okay, so in that case, we can apply also L'Hopital rule if we have infinity over infinity indeterminate form. Okay. Or for the some other indeterminate form, we can convert our problem by taking that from logarithmic functions 0 to 0 or infinity over infinity indeterminate form. For the infinity over infinity indeterminate form, we have the same rule. Okay, so I mean limit x goes some numbers, it can be infinity or minus infinity again. F of x over g of x, if here we have a infinity over infinity indeterminate form, you can apply L'Hopital rule and you can say that which equals f prime of x over g prime of x. Okay, of course here if you write as a theorem form, here limit of f of x is either minus or plus infinity, and limit of the g of x is either minus or plus infinity. Actually here this quotient can be minus infinity over infinity, or minus infinity over minus infinity, or infinity over minus infinity. It does not matter. You can use the L'Hopital rule by this way.